I think we're in the fastest changing, world I have ever seen in my lifetime. I mean, it's a fascinating time to be in the space.
I think, to me, the best analogy is like, imagine if we discovered a fuel that gives you 100x more energy. How would you use it? Like, would you put faster engines in the car?
How do you make agents autonomous for a week, a month, so that they can complete tasks that a human software engineer would take, a week or a month to complete?
So you think that with prompts, has the bar been lowered for what can be done in the industry now?
Because everybody agrees that you will be programming computers in 10 years. But how will you program computers? If the computers are agents. So the point is, we're learning when we're creating those training camps for the agents that this is called reward hacking.
The speed at which I can develop software and deploy it is today purely gated by the speed at which I can validate the software.
I think AI has gotten into the engineering challenges now, which is good. It's gone from research to science to engineering, which is a great place to be in.
I think the magic of memory is not really what you remember, but what you forget.
Good morning, folks. Thanks for coming down.
Good morning.
Looks like it's going to be, I heard somebody say yesterday that this week is the wettest, Bay Area is the wettest throughout the entire planet. I'm like, wow, let it come. So we have a lull before the storm, for the next 7 days. But any plans for the holidays? You guys are going someplace?
No, I'm around actually. I'm working with my little one on her programming contest preparation.
Nice. And you can stay back home then.
Yeah.
I have to watch a really good Indian movie that's come, I heard. It's called Dhurandhar or something. 3.5 hours, but Alex?
Not very much. Just preparing a lot of final data sets that we have to deliver, and then a little bit time with family. Yeah.
Got it. And how is teaching? Are you taking any courses?
So we just finished the final. I discovered the value of the pen and paper final in class, in person, no machines.
Oh wow!
And that I think is the AI proof way. And we encourage the students to say, okay, you can use AI to study. It's an amazing personalized tutor and all that. But at the end of the day, you will be tested in a real in-person scenario, and I think that changes the way people think about, I actually have to figure out how to do this without the machine. So I can use the machine to learn. But so I think that's how we're doing it for now. And it's of course a challenge to deal with how you teach a class, but it's also very helpful.
So memory is still important.
I mean, you want to exercise. The thing I'm thinking is, nobody asks why do people still run, when we have, cars and bicycles, but people still run to exercise. So in the same way, exams are there to exercise the mind, right? So,
I like it. It reminds me of Steve Jobs not giving iPhone to his children.
Actually, I heard one founder banned use of LLMs for first 3 months for college grads.
Really? Wow. That's a good media news as well.
Yeah.
Speaking of best practices, we were just talking about the industry at large and so on. So, we'll talk about industry and academia together. But you had a few questions on what we are all seeing in the industry, but I'll let it...
So I since we last spoke, what is happening from the industry trenches, and I can tell you what I'm seeing in the academia and research side. But tell me what you're seeing.
Yeah. I mean, I think the fear of LLMs definitely is subsiding, even though I saw an article in the Information yesterday about how Salesforce is basically coming out and saying that people are beginning to distrust or mistrust LLMs now, which I think is like sour grapes, honestly. I think you can't get simple things to work.
Yeah.
I feel like ChatGPT and Gemini are everywhere. So as it kind of embraces us and we embrace this in our personal lives, it's seeping into the business world quite comfortably now. There's still a huge hunger for integration. Like, how do you really get all the legacy data in? And doing it well is still hard. Like, if you have 10 terabytes of unstructured documents, how do you index it? Versus, am I going to use, the MCP of the legacy system and it was not well designed and so on. So this whole idea of where will the new data sit?
Mm-hmm.
Am I going to put an MCP on the old data, or am I going to bring the new data and organize it differently in more optimized AI-friendly ways? So the whole integration challenge is still real. And it includes things like identity and permissions and all that stuff as well. Of course, freshness and latency and all that too. But I think AI has gotten into the engineering challenges now, which is good. It's gone from research to science to engineering, which is a great place to be in. And I think the idea of surfaces, like, okay, how are people going to consume all this stuff, is also something that we are seeing a lot of, which is it a mobile app? Is it a desktop app? Am I going to use a web agent for like a web UI to do some of these things? Is front and center. I don't know what you were saying out there.
I think, to me, the best analogy is like, imagine if we discovered a fuel that gives you 100x more energy. How would you use it? Like, would you put faster engines in the car, and then like, do you need to change the way traffic works, or do you build like train tracks so that you can actually have trains move super fast? Like, how we're going to use this thing so that we can get benefit from now and future after some infrastructure is built is still very much an open question.
Mm-hmm, mm-hmm.
And I think the equivalent of train tracks here is essentially context engineering, right? Like, I can get really amazing answers from this thing if I can pull all the necessary context in place.
Mm-hmm.
And like, a lot of people are doing that manually, but like automating that process, finding the right use case where it's worthwhile to do it so that you can get some returns in next few months.
Mm-hmm.
It's still very much an open source problem in my mind.
I'm smiling because, when oil was discovered, there was so much struggle to even just get it out of the earth. And there's one of my favorite movies is There Will Be Blood.
Oh, yes.
We have to watch it together.
Yeah,
maybe one of the next podcasts should be we watch it and then we go and comment on it. Because there's blood right now in the world as well. The other piece in the industry that, again, going back to the world of permissions, is visibility and organization. I think, how do you organize? Because, we organize humans in hierarchical org charts and things like that. And people are now, there's entropy in the system. We're building agents, building more agents. The question is, where do you host them? Mm-hmm. And how do you do it in a way where what I'm building is not mucking around with the rest of the company or your team and things like that. So at least we are very gung-ho about organization, like, the idea of team structures, projects, portals, portals, both internal portals and external portals with customers. Like, these are all the things, the way you house people and customers. Mm-hmm. That's how you're going to house agents which have access to knowledge just within that one team or within that one project or portal. So all the mundaneness of organization and visibility is actually showing up.
I want to add one thing from what you said. I think there is a dichotomy right now in how agents are built. One way is you call the tools before you bring, let's say some user is asking about, the product or let's say a credit card they own or a loan or something. And you may have some internal data that will help answer the question. You can bring this data in the context. So you say, here is this user, here's what we know about this user, answer the question. And now the LLM doesn't get to choose, right? The LLM just wakes up and sees the question with all the context provided to it. And the other approach that I see in more autonomous agents is the agent itself invokes tools or is given like Anthropic released skills, which actually I think a very interesting technological development. Skills are basically folders of scripts. So if you want your Cloud agent to, let's say, work with PDFs, you're not providing all the PDF tools in the context. You just have this directory structure, and I think the agent itself can say, oh, I'm dealing with PDF. Let me go look at my toolbox to see what I have. And there's like files with describing the tools, and then the agent can dive by navigating, I think, the file system effectively and find the tool, the right tools and skills.
It's very interesting you said file system, because the team structure, let's say sales team, is also like a file system. Because you have France, you have Western Europe, you have EMEA, and you have global region. So in some ways, everything that you organize is hierarchical.
Right. And the question is, does the agent find what to retrieve or what tool to use itself, or do you hard code, or do you provide, or dynamic? You could not hard code it in the beginning. You could have another LLM that observes the conversation and starts injecting into the context the right things, but the agent is passively sitting there, it just sees information arriving in its context, or the agent can actively search a tree and find. So I don't know how.
I'll tell you how we are thinking about it.
Yes, please.
So each of these sort of homes, let's call them spaces, team is a space, project is a space, portal is a space, they're all spaces, So let's look at team and a hierarchical team. And each of them has people and an agent. And by the way, if you're at an EMEA region, then you get to see everything down below, because it could be forecast for this quarter, sales forecast. So you're allowed to see Western Europe and France and Paris and so on and so forth. But anybody in Paris is not allowed to see all of France and all of Western Europe and all of EMEA or all of the world. So there is this whole hierarchy that's built into what is visible and what's allowed to be seen or not. So if you're here, obviously, and I have my own agent for my emails and my calendar and my notes that no one else is allowed to see. So there's an inherent hierarchy built into my agent, my French agent, my Western European agent, my EMEA agent, and my worldwide agent. And finally, the web search and OpenAI and Anthropic have their world knowledge as well. So there's a whole hierarchy built in. Computer, as we call it, is going to unfold all of this in parallel, because I don't have time to do this, at 6 levels, different levels, and take 4 seconds each and so on to get this. So it's going to unfold in parallel and then find if there's a skill that matches that actually does the job. So. And there could be disambiguation because you might have 2 or 3 skills, but we have to do all this in parallel. And each of them has an MCP as well. So I have an MCP, the region above has an MCP, and they all have skills and they have knowledge, and there is a extra agent as well. And I have to just find all of this stuff in parallel.
So I guess another thing that relates to how industry is evolving now, based on all these tools and different specializations, there is the frontier labs, which are making the models. There is this, neo labs that like Reflection, which are basically gearing up to train models. But there's these agent companies that the agent companies could be in verticals, or they can be general coding agents. And then they're primarily creating a lot of tooling, and I think there is so much interesting stuff to do on the tooling side and the skills and context engineering. So I think that's going to be a very, very active space now.
Yeah.
And the other question is, how verticalized will they be? Will they be super specialized, or they will still make something like Cloud Code, but it will be just, I think a few companies like Warp are doing coding, general purpose coding.
Interesting.
Yeah.
And the other piece is around the metaphor of networking, because in the 90s we obviously were creating machines and adding machines to networks very fast because of the internet and the fact that we had 100 megabit and then eventually gigabit in networks and so on and so forth. And we had new protocols that emerge to discover machines as well. I mean, the way we organize things in DNS and the way we put things in DHCP and the idea of VLANs and LANs and ARP and reverse ARP and things like that. How do you broadcast to actually find machines? I feel like agents, if you just think of them like machines, we'll have to think of these protocols to actually discover them as well. I think we're very early. This is like 1993 right now. Yeah. In many of these ways, just because we discovered Ethernet doesn't mean we know everything about machines and the way these things are organized, World Wide Web as well in some sense, so I think that's about the industry. What about the academia? You talked about autonomous agents and things like that, but what are you seeing in the last 6 months?
Yeah, so one trend is that agents have this, I call them workflows really, they're not real autonomous agents. They're basically a fixed graph with predetermined prompt steps like a line graph tree. And these, I think, are now working pretty well. The models are so good now that if you want to make a standard workflow that, you have like 5 things you want to do and you basically want to navigate, your users navigate between 5 or 10 standard things, the number of steps is the key way that I think you can measure the complexity. How many steps does the agent have to do? And I think in 5 to 10 steps, the agents are now very good with some prompt optimization and so on. I think where the biggest research challenge, the frontier challenges, is what's called long horizon agents that are truly autonomous. The agent hasn't predetermined the number of steps that it wants to do. It's running in what's called a React loop, and it decides what to do next. It decides when it's finished, and these are truly autonomous agents like Cloud Code and so on. I think the number of steps, also the horizon, also the amount of time it takes, we are now pushing that, and I think this will be the next growth axis. Is okay, now you can do tasks that take 10 minutes. Can you do tasks that take 1 hour? Can you do tasks that take a day, a week, a month? And we're trying to measure this in academia and in research by making benchmarks that are increasingly harder. So terminal bench was one that already is pretty hard, but as the state-of-the-art agents are getting higher and higher, we released terminal bench 2. We plan to release, terminal bench 3, and we want to stay in distribution, which means the things you can do with, access to a command line interface, including, Bash, writing Python, but also it can be other like data science tasks. If you see the distribution of tasks that the agents are doing in terminal bench, they involve quite a wide range. But what is going to grow is the depth of the task, the duration. And I think that's how we will be able to keep agents challenged in the next few years, is by longer and longer horizon tasks and more complex environments.
And why do you think Bash and file system and all this stuff that we are trying to build scripts around, why are they not in the MCP parlance? Like, why are they not just part of tools? Why are they not just called tools in MCP?
Because at least in the terminal bench philosophy, there's only one tool, and it's the keyboard. And if you have a keyboard and you have a machine, you can use Bash or you can write your own Python tools. And that's, I think, the way that humans also operate. One situation is if there's predetermined workflows and they involve using these 5 API calls, that's fine. Just build those 5 API, just give them access to tools. But I think the trend now is, at least for very complex autonomous agents, you just give them a computer, a Docker container, you give them Python, and then they can write whatever they want themselves. And this is how I think the really complex agents will be developing.
But sorry, go ahead.
I was just saying to give everyone a flavor for what's in there. Can you define one task in like terminal bench 2 or?
Yeah, so tasks can be things like I give you a CSV files and I say these files have sales, but they have like noise in them, and they have you have to maybe do a join, and you have to compile this new table that has only the customers in Asia, and I want you to only select the name and the email, and I want you to clean it up. So the agent can find multiple tables that can be given as CSV files. Or, by the way, the other thing is if you give the agent a task, it can be easy or hard depending on how you give the task. If the task is already in a single clean, database loaded, and you can say you have access to this database, then it can be a single SQL query. But if you just give it some raw text files and you say figure it out, clean them up, join them, now the agent can use grep, it can even write its own scripts. So the environment is describing the task. It's not only the question find this customer or make this table, but the environment describes the set of the world, how the world looked like when you started doing something. And if you just gave me, here's another thing, you can take this task I just told you, but you can also say, now I zipped all those files. And I also encrypted it, and now you have to break this encryption scheme. So actually some of the tasks break this basic, there's some standard easy encryption schemes you can break by knowing, for example, it's a zip file. So like how the first byte should be. So now if it's a very trivial encryption scheme, so we have tasks like that. So the agent has to, there's security tasks, data science tasks, classical command line, install like Linux, and like all kinds of very general tasks you would expect any good software engineer, DevOps, data scientist. There's also scientific computing. There's using obscure hard tools. There's playing games. So
I was just thinking, basically, in production, we're trying to use MCP as a way to list things, tools, even agents as entries in MCP. Is it time for us to include MCP in the least common denominator of things that terminal bench should be using?
Yeah, MCP is fine. The real question to me is, how much do you want the agent to autonomously do? If are you giving it a file system, for example?
No, I'm giving it a bunch of tools, and it can conversationally discover what these things are. But there's a protocol now, and it goes over a network. I don't have to everything be in a local file system with scripts and bash and things like that. They can all be behind MCP. I'm wondering if that is going to help the production systems be close to test systems.
That is definitely the way to go for some types of agents and some types of tasks. The time you need a file system is when you need intermediate files, right? If you want to clean up some CSVs and create some other files and and install install some new package, then the agent will say, oh, I need this new Python library, let me install it. So now I need a whole file system and a whole working Python. And if my Python is, like one of the tasks is my Python is broken, so installed Python and broke some file. I don't know if you've been in this hell of so some dependencies are broken. So that's an environment. The task is fixed by Python, but the real task is the environment describing what actually happened. So the task there says install Python, the script that sets up the task deletes some files, and now the agent wakes up, and now the agent has true autonomy, and it has a working space where it can start trying different things and figure things out. If you only have some MCP tools hard-coded, I think that's fine for some types of jobs, but if you really want to give autonomy to the agent, you have to give it, I think, a Docker container.
Got it. Maybe one last thing on the industry. We talked about structured, unstructured data. Any sort of summary of our last conversation that you want to bring out about the industry? And then we can probably talk about some deeper academic work as well.
Yeah. I definitely think that for the last, 20 years or so, we wanted to understand complex systems, and the only way we could understand those complex systems was enforcing the raw data into certain schemas and then aggregating using SQL or whatever, right? Python. And that was the only option available.
That was your previous company, thought so.
Yeah. But imagine, my favorite example is this, because that's where I'm spending a lot of time. Imagine forcing someone to fill 20 fields about where the opportunity is versus just having a conversation with them. And the fidelity of information you get in that conversation is so much higher. Like you hear the hedging, the hesitation in the way they describe things. They will bring up something that is not relevant for any other deal, but is relevant for this deal. There's so much other things that's in there. And we know how to process this information in the context of a single deal, but we don't know how to process this information in the context of 1,000 deals. And that's the fundamental change that we're seeing can happen, right? So let's say that your culture is rotten in a way that the sales rep and sales engineer don't trust each other most of the time. Can you really figure that out by looking at this data? Let's say that your A's actually do not believe in the new feature that you're launching, and it shows up in the way they're talking to customers. Can you figure that out? You could have never figured that out using structured data, stuff like that, but now you can.
Yeah. You know, it reminds me of, I was at a data warehousing company, Aster Data, between 07 and 09. And we had started to talk about high volume data, but low value. High volume, low value. And MapReduce became the thing around that. Like, you can't use SQL for all that. You know, there's too much high volume, low value. And looks like we are having the same discussions again. That look, this is high volume conversational data. And by the way, there's going to be value in some of the things like, you know, politics or lack of enablement and things like that. Do you see this to be as or more relevant in B2C companies where there's maybe millions of customers and tens of thousands of discussions a month, or also in B2B companies where they're basically doing a lot of things with a lot of like physical enablement and, you know, management of 7 people and this and that. So how do you see this B2B versus B2C?
It's relevant for both. So there's one car company that we're working with where they sell essentially 100K cars, and the transaction happens essentially in one day. So the conversion rate is around 10%. And if you're able to just boost the confidence of the salesperson, that conversion rate can easily go from 10 to 15%, and that's essentially 50% increase in billions of dollars of revenue, right? But I'm working with another B2B company where you wouldn't know it otherwise, but when you look at like hundreds of transcripts, you realize that everybody is struggling with objection handling. They just like so many times people bring up that like I have this existing way of doing it. What's the difference? And everybody's like giving random answers. And it's extremely valuable for this company to learn that the people are not able to handle these kinds of objections, and then use that to go and teach it. And could you have figured it out traditional way? Yes, but the latency of that process is 6 months.
Absolutely. And the managers might not be equipped as well. To mentor them. So this idea of a personal assistant in some sense and a co-pilot looks like it's really taking shape in the industry. That's awesome. I mean, one thing that we were talking about was also there's a funnel of work. And you know, you talk about collaboration software, creativity software, which is the top of the funnel. There's a lot of ideas up there. Then there's productivity, which gets into email and calendar and you know, things that we've actually used like Google Docs and Google Sheets and things of that nature. And then there is the business software, which is where you connecting it to your incidents, your customers, your tickets and things like that. And looks like we need to think about AI agents at each layer here. And what do you do with this data? Because there's Slack data up there that's also is conversational in some sense. There's data from emails and calendar invites and meetings and things like that. And then finally there is data that I'm sharing with everybody, including with my customers. And I think there are contracts that we are having with our customers, and they need labels on like SLA violations and things like that. So the deeper down you go, the more they expect you to label things so that they can come back and say, my job is not getting done, and so on and so forth.
Yeah.
Fascinating. So that's about the industry, looks like. Maybe moving over to, some of the recent work that you've been working on, Alex. Talk about your last year worth of just evolutionary thinking from SFT to SFT plus RL to and GRPO to now what you're talking about is GEPA, GEPA. Maybe you can even explain to the users in the acronym GEPA itself.
Yeah. So so now we have December 2025, and I guess in January 2025, DeepSeek R1 came out, and there was a whole revolution about how you can make agents think with the thinking tokens, because DeepSeek R1 was the first model that showed its thinking traces. And, everybody got very excited when we realized how easy it is to endow thinking into a non-thinking model by just creating thinking traces from one reasoning model. The only one that existed at the time was DeepSeek R1, and then performing supervised fine-tuning SFT starting with a non-reasoning model and teaching it to imitate the teacher, right? So that was, I think, the big revolution that happened in January. It started in January 2025, and the big problem there is, okay, how do I now create data sets of thinking traces, and how do I train models to do these thinking tokens? And there's a lot of trade-offs there about how long is the thinking, so which introduces latency, but it also increases performance. How do you measure reasoning in terms of the standard reasoning benchmarks like AMI? These are now done. Basically, at the frontier models, they all, as far as I understand, have saturated the AMI competition. They've gotten a gold medal in IMO, and it's incredible progress. So reasoning is, basically, and when I say reasoning, I think a lot of people, are thinking something more general. Reasoning to me means how you perform on the reasoning benchmarks. And reasoning benchmarks are very well defined. There's 5 or 6 of them. And basically, AMI, for example, the most well known, is fully saturated now.
It reminds me of in India, there's so much emphasis on entrance examinations.
Right.
So intelligence was tied to how well you do in the entrance examination.
Exactly, and that is actually a very valuable thing. It's because it's obviously a very imperfect way to measure, and you shouldn't say intelligence, but the performance of measuring things very carefully allows you to super focus and improve that capability. At some point, it becomes overfitting to the capability and not reflecting what you started with, right? But benchmarks shape the field and actually drive progress. And then at some point, you become over-indexed. So, ImageNet, for example, not many people care about it right now, but it truly drove the field. And I think AMI also drove the field. But that benchmark now is, at least for frontier, is saturated. You can say I want to make a small model but it's not, doesn't make sense to say I'm hill climbing AMI. So after reasoning, I think the big trend is definitely now long horizon agents. How do you make agents autonomous for a week, a month, so that they can complete tasks that a human software engineer would take a week or a month to complete? I don't believe we'll be able to see this in the next 6 months, but maybe we'll be sitting here in 6 months and say a year worth of cloud code can now do a year worth of work. So I don't know, but I don't believe so. But I believe this will be. There's this projection about how the length of coherent tasks scales in time. They say it doubles every 6 to 7 months or something, and you can extrapolate from that. So definitely, there's one big research direction. Another very active thing is the continual learning problem, that we all understand that when you have an employee, as they spend some time in a job, they actually shape their brain, they learn on the job, whereas LLMs do not. Every time you talk to Claude, it's like it rebooted itself, right? So that is, I think, one of the main problems, like memory management and continual learning. is one of the most important areas of research. People are trying to figure it out. There are some obvious things you can do. You can take all transcripts, you can give them to GPT and say, hey, here's a bunch of transcripts. What are the most important things you need to remember? And it will produce some lessons learned or some short things, and these are added in a memory bank. So I think frontier models are also doing this, and they can also show you the memory, and you can, I think, delete in some of them adaptively. So this is obvious.
And what are they doing in the background? Are they just appending to the prompt and then?
I don't know exactly. I believe there's just a little, here's good things to remember, and I believe they just added to the prompt.
So like a system prompt or something?
Yeah, they added a memory, there's a memory thing to the system prompt, and as long as this memory, this is a very, very basic memory mechanism. It doesn't, our memory adaptively retrieves things into our consciousness. It doesn't just dump everything I need to remember in my conscious mind all the time. In every sentence I speak, I'm not pre-appended with.
Yeah. But it's mindfulness, in some sense, mindfulness. Like the way we talk about the word values and will and skills. This is the way we interview people is, okay, do we understand their values?
Yeah.
And looks like it's a lot of the values things that will be keeping the LLM mindful. You were saying something?
Yeah, I was just trying to say, so there's obviously one approach where you have a document full of information and you could use retrieval techniques to retrieve the relevant things, or you could say these are the most important things to remember, always pre-append, and some variation of that, right? The other thing could be something like LoRa, right? Where you have your core learning, but you're layering something extra on top,
right,
based on what you have remembered, or even you could think of.
But LoRa is editing the model?
Yeah,
Yeah.
It's editing the model. And the problem with that, so you're absolutely there, that there's two ways to have memory personalization.
The third one I was thinking was could you do a mixture of experts kind of thing where you're building a few expert layers on top that for each context you have something additional training.
Yeah, so that you have all three.
Yeah.
you have gotten all three perfectly correct. So the first thing is just have some memory and just hard-coded sentences. And the sentences can be from one document, but think of you work with Cloud Code on a specific repo for a month or two. And then you have some preferences about how you want to edit things, how the style of how you like to write code and all that. It's one easy way to personalize, let's say, Cloud Code for your repo for you would be to give all these previous transcripts to a model, ask it to extract some important lessons learned, and then just have those lessons learned there and say, remember, Amit always likes this, always does that, blah, blah, blah. And that's just something appended to the context every time you use them. Okay, that's the dumbest possible thing, and of course it's still valuable and people do it. The next step after that is, can you do something that's task specific or optimize the prompt so that you continually learn with maybe skills, and I'll talk about that. And the last thing is, can I have models that have weights that I can update? The problem is the frontier models, we cannot update the weights. The only thing we can do is build prompts. So because of that, only prompt-based techniques can be used unless you have what I call advisor models, which are small models that are whispering prompts to the big model dynamically, and then the advisor model you can actually personalize or have it continually learn, but you still are riding on the powerful big model because the advisor is just saying, remember, Dheeraj likes this, and it's not just a hard-coded sentence, it's something that comes from a small LLM that has been LoRa'd or fine-tuned or RL'd for the specific user. So this is kind of the hierarchy of what we see in research. But even in prompt optimization, now I think the thing that's taking off is just vanilla prompt optimization for specific tasks.
Do you think a year ago you would have said that?
No, I wouldn't. I wouldn't have said that, I think. I think I would have said that open weight models are going to catch up, maybe more, and there will be more SFT and RL. I don't think, I think the open weights are catching up, but not in the US. So that's another problem. Is I think the Llama ecosystem is not happening anymore, I suppose, and I don't think there's many. So we have a little bit of an open source problem in the US, and I think we need to make sure there's enough resources in the open
And
source.
it's not just open source open, it's also people's ability to grasp how to run this thing and how do you optimize this thing and so on.
Yeah.
I think, let's say that we have a few million developers in the US. Let's say the number is, I don't know, 5 to 10 million people in the US. I'm pretty sure that 9.5+ million people are just trying to figure out how to do some basic workflows with some, Ask LLM nodes in them and so on. Which, by the way, is immense progress. I don't think we should even look at this as anything else.
Of course.
We tend to go on harder problems, but the simpler ones done right with higher quality alone is actually a long achievement, actually.
Yeah. Training is very, very hard. You need, and the hidden, there's the expertise, which is locked primarily inside frontier labs and is very secretive. In the universities and in the open source community, we try to replicate those efforts, but we don't have the compute, especially the pre-training is an enormous investment. And the other is the data, right? So having high quality data sets is extremely expensive, it's extremely difficult to curate. So that, I think, for general purpose, it's going to be very, very hard to compete with frontier models. And what is much more meaningful is to do it for your internal data or your internal processes. So that is what we're doing with Bespoke. So Bespoke, we try to help enterprises create their own agents on their own data, but we curate and then primarily do context of evaluations, number one, we're going to talk about, and then context prompt optimization with JEPA, for example, and then finally SFT and RL.
I feel like one of the reasons, this is a philosophical thing, I'll say this, but it's a controversial thing to say right now. I think Europe, in the 25 years ago, if you look at Linus, at some level he was American, but he was equally sort of rooted in Europe, and Hickey from InnoDB and MySQL and all that. A lot of the rebellion of open source actually came from European folks. And I think in the last 25 years, Europe has lost its way. I think it's preoccupied with other things. There's probably, Europe just is about rebellion against Microsoft, against Sun Microsystems, against IBM. We've got to go against this. Right now, all that is happening in China, but it's actually a walled garden. And nobody wants to actually go and collaborate and so on. So I think there's probably another reason here that people are in Europe are actually quite preoccupied. I don't know if you folks actually feel like that.
I'm not seeing any, I guess there are a few exceptions, I think Mistral, but there's very, very few things that I'm seeing in the models and the agents from Europe or India. There's another, China is doing incredible progress, and the US, but the rest of the world, I don't know what combination of universities, funding, open source, regulation.
I guess there's a few good things coming out of UK.
Yes.
Right? A lot of deep mind core research happens there. And then,
but it's still part of Google.
Yeah.
Right?
And then 11 Labs.
Yes. There are a few, but not proportional to the size of the economy.
Yeah.
And what you would expect, I think. Yeah, and I think Europe is trying to figure this out, and there are people who try to help. Also startups, right? I think there's not that many compared to, it's supposed to be, a very large economy comparable to the US.
So you think that with prompts, has the bar been lowered for what can be done in the industry now, are we going down the path of using better techniques for prompt tuning than ever before? And maybe that's the thing about JEPA, and you talk about JEPA.
Right. So let's talk about that. I think that is a very important thing now. So the one thing is prompt optimization can be you write a single prompt, but then when your system gets too complicated, instead of having one prompt, you can split it into multiple prompts. Let's find user intent first, and if they want to get a new credit card, you do this. If they want to open a loan, you do that. If they want to talk to a representative, you do this, blah, blah. So that's like a line graph type of thing. And basically, instead of writing one prompt, you write multiple prompts. Now, these prompts are written typically manually, and then the number one thing is nobody is systematically evaluating. What they mess around with the system, they run a few things, like, okay, looks good to me. But the number one thing I think everybody needs to start with is have a systematic evaluation for their agent. Like 100 questions and answers, so that when you change something, you push a button, you say, oh, I went from 71 to 78%. That's a good thing. If I went to 61, that's a bad. So I even push a button and evaluate. So that's the number one thing to do. The next thing is, if you have data, how do you update your agent, optimize your agent, your prompts, your single prompt first, maybe your DSPy or line graph program next, in a data-driven way, right? So that is, I think, what JEPA did so successfully. This is JEPA, by the way, with a G. So genetic Pareto is what JEPA stands for. It's an evolutionary algorithm that treats prompts like little, animals and evolves them. But the interesting thing about how it does evolution of prompts is, if you just have your whole evaluation set and you just say, hey, GPT, here's a prompt, I score 71%, look at the transcripts, you give it the transcripts, it's very important, the answers, and you say, can you improve the prompt? And then that's like an evolution step. But the problem is, if you just give the whole data set, it will try to find a prompt that improves on everything at the same time. And also 100, trajectories is too much to give. So instead, what JEPA does, previous techniques were doing that. They were just evolving a prompt using an LLM on just some set. What JEPA does is it picks randomly a small set of questions. It asks an LLM the reflection LLM to update the prompt. If the new prompt is better on the small batch, it keeps it. And then it runs it on a whole validation set. And it keeps track of a record of the new prompt. Maybe it does better on some of the validation set. So it keeps what's called the Pareto set of prompts. So it may know that, for credit cards, this is a good prompt, for loans, this is another prompt, for customer support, this is another prompt. So it maintains a whole set. And then finally, it may extract only one, or you may make dynamic versions of JEPA that we're working on now, that when you get a question, you route to the right query and so on. So there's a lot of interesting things going on now. And also in Berkeley, there was a whole course being taught about genetic algorithms for optimizing programs. You can think of optimizing prompts, but you can also think of optimizing line graph programs or even Python programs. Like OpenEvolve or AlphaEvolve are also along those lines. I think that's going to be a very important direction where you use LLMs to optimize your systems.
And first of all, there's a dynamic nature to this. So there'll be oops moments along the way as well. But also things like catastrophic forgetting, the kind of things that we try to do with smaller models and things like that. And hopefully we don't devolve back to the intent-based chatbots of 7 years ago, where there's a lot of if-then-else built in.
Right.
And it was never able to go back and try something else. Do you think we are in a better world than that?
The models themselves, we have seen, are much more flexible. If you add distracting things in the prompt, they are extremely good at not ignoring it and picking the. So far, it's surprisingly robust.
Yeah.
So you may add a lesson learned that only applies to very specific workflows, and so far we haven't seen for the frontier models that creating problem in other cases. Actually, we've been training advisor models, so that is the next step after JEPA, which is dynamic prompting by an LLM. And sometimes when we start training the advisor model just says stupid stuff. It just says, try harder, or because it doesn't know how to advise, right? It's like, think of a Quen model trying to advise a powerful GPT-5, and then trying to solve a problem. And then it said, you're going to see this model is going to try to solve a problem, try to help to advise it. And then Quen says, think hard, or think step by step. So something stupid like that. In fact, sometimes it would even produce wrong. We have actually studied giving bad advice, and still the big model is very robust to that. The benefit of the small model, of course, is you have its weights. So now you can actually do RL on the small model, while you still have GPT-5 doing most of the work. And I think this compound architecture, where some things are trainable with weights, you still have prompts. I think this is the way that agents will be built in the future.
Well, speaking of, sorry, go ahead.
Yeah, please go
No, go ahead.
I'm going to maybe derail this conversation completely.
You probably already have.
But I'm very tempted to now do this thought exercise. So we are at a phase where we are trying to figure out who's our ICP, what's the message, what's the prompt. And so there's like three things, right? Like a narrow industry segment, like maybe we have like three products. So which product to talk about, or which set of products to talk about. And then who do we target and where? So we are manually doing this exploration of like pick a narrow group of 50 people based on some criteria, then figure out, okay, what message should we send, which product should we talk about, and then send a few messages and see what the return comes back. This kind of thing seems like perfect for the long horizon thing you're talking about. Let's say if we were to design it, how would you go about doing that?
Do you have training data where you send
the training data is coming from the
So
the
it's
real
dynamic.
world as the environment,
So
right?
it's dynamic. So it's dynamically saying, okay, let's try. So you say you could have some LLM with JEPA optimized to send out marketing, sales messages.
Yeah. So I have, let's say, 20 pages of descriptions of like there are three products. This is what they do. This is the benefit they bring.
Yeah.
I have 10,000 contacts with some information about this industry, this size.
This would be amazing if we get this right.
Yeah. And the reward is clear, right? So the beauty of this is you have clear reward. The reward is if the person responded. The moment you have measurable rewards that are easy to measure, these techniques definitely will shine, I think. Yeah.
So, I mean, just to get this end-to-end covered, like captured the pixel, because you might have to send a pixel for this prompt versus a pixel for that prompt, and knowing which pixel is being opened and which pixels will be responded to. You just need to end-to-end finish this thing.
I see.
That's why I was saying that I might derail this conversation if we try to design this.
What you're saying is that in reality, because this is a great sort of concept of JEPA, the question is when rubber hits the road, what do we need to finish off in this process to get these ideas to be in practice?
Yeah, my understanding of trying genetic evolution techniques and also advisor models in a few different domains is number one is there a clear reward?
Yeah.
That's the most important thing. The second thing is, are there lessons learned that transfer to other questions, right? So for example, if the questions, like in the terminal bench original benchmark, running JEPA has been challenging because the terminal bench tasks are completely diverse. There's a task that says play Zork. There's another task that says fix Python dependencies. There's another, and now the reflection AI looks at how the agent performed and tries to get some lessons learned. And there is no lessons, I suppose, learned from Zorg that transfer to Python, right? So I think it's better to have a narrower problem, but you don't have this issue. You have basically the same task all the time.
Yeah.
So then there must be lessons learned.
Yeah.
And then either an LLM can discover them by looking at trajectories. I guess in the marketing situation, there's only you send a message in, you see if they click. There's not much you can reflect on. I guess.
So sometimes people might say, okay, I'm interested, I want to take the meeting, right?
I see.
And sometimes you just see that the email was opened.
Right.
And sometimes you see that like LinkedIn connection was accepted.
Yeah.
Right?
Yeah, so you could automate this process and give it to a reflection LLM and say, oh, why do you think this worked? So it will try to find patterns about when it works. But I guess the same thing that we do, right? Yeah, so it's exactly, you're just automating what we do,
We're trying to figure out like maybe people who are selling insurance and are like less than 50 sellers, do they see this problem or like is it like the car companies that 700,000? So
well, it just goes back to like this idea of, let's say, advisor models, or the fact that you're continually learning and editing the prompt, which company can we engage with to say, hey, give me some software that basically does this for my software?
Yeah.
Like, are we productizing these things at Bespoke or wherever? We say, hey, let's take these things, or can we work with UC Berkeley and research to actually, I mean, that's the kind of stuff that at least would be useful to understand.
So the JEPA project is an open source project that started in UC Berkeley in the Sky Lab, led by Lakshya Agarwal, who's an amazing PhD student. And there's also many other great students and faculty who helped in the project. It started from another project called DSPy, which is another open source project, but now it also has a standalone version. So the open source community is one way that many people can engage into this. And then Bespoke Labs is one company that's helping companies create the data and use JEPA and JEPA++. So JEPA is the open source, but there's many additional new things that can be done on top of it, from advisor models to techniques that have multiple prompts active at the same time, or evolving JEPA for multi-turn and tool use. That's another one limitation, by the way, is when you have multi-turn and tool use autonomous agents, it's actually harder to give a whole discussion to a reflection LLM and try to get a prompt, because the prompt will be used at every round of the discussion. So there you may need to have something more dynamic, not just update a prompt that's used in every turn, but have something like an advisor model that is injecting advice only at the relevant point.
So
right? Yeah.
Now I'm getting very curious about these advisor models. So you gave one bad example of like try harder.
Yeah.
What are some of the good examples you've seen where advisor models help?
The most direct way where it worked in our paper is we had the task was summarize a news article or a paper. So the task is summarize this. Here's an article, summarize it, but it says summarize it for Alex or summarize it for Matej. And then you just ask a model like GPT, it produces a summary. Now the interesting thing is you see a reward. Now what the students did is they said the reward is Alex likes long summaries with details and Matej likes short summaries. But nobody knows this. Okay, that's the interesting thing. The only thing that the system sees is a reward, and initially the advisor is a Quen model, and then it is prompted to say, you're going to see a task, try to help increase the reward. Okay. So initially it says something stupid, like try hard. and there's a summary, and then it sees the rewards. And then we do RL, only on the weights of the small model. The GPT-5 is just fixed. And then the amazing thing that's in the paper is you see how the advice evolves. And from a data-driven way, the Quen discovers that when by chance the summary was a little longer for Alex, it got a higher reward, and for Matej when it was shorter. So the advisor learns to say, remember for Alex, he likes longer summaries with more details. And when Matej comes up, because this is a dynamic thing, right? So the question is, summarize this article for Alex. Advisor says, after it has been trained, remember Alex likes short summaries. And when the prompt is summarize this article for Matej, advisor says, remember Matej likes very concise. So that type of dynamic personalization cannot be done with JEPA, because JEPA will just have a single prompt. I guess it could say, Alex likes long, Matej likes short. But if you have 10,000 users, you will have to learn this from 10,000.
So you just have to go through that extra model.
Yeah.
To at what in the pipeline, where does this extra model sit?
It just observes the question. It sees the question and produces the advice, and then the model is run. So it's like a pre-processing step to the query in the simplest case.
But again, pre-processing to edit the prompt that goes to the foundation model?
It adds a line to the prompt. It adds a line.
line.
Yes, it says, I'm the advisor model, here's what
So it's a data-driven way to really do this, as
Yeah.
opposed to hard coding if Alex, if Matej,
Right,
and so
exactly.
on.
It's a data-driven way, and it's trained with RL. So that's interesting. thing.
How does your environment know what Alex likes and what Matej likes? Are you literally reading it, or?
Oh, in the environment, we hard coded the rewards. We said in the environment we have virtual users, and we say if it's Alex, he likes long and so on. So the environment in a real situation, you will be sending emails.
Reasoning traces maybe.
Yeah. Or you will observe how your real users perform, but you will have these rewards signals, but you will not know what works. You just want data-driven way to discover.
And is it as clear as that, or is it like mixed with a bunch of other things that like sometimes Alex likes long when it's actually talking about a topic of his interest, which is RL, but
so we
likes it short when it's news article or something.
We did try very complex, but that's actually a great experiment.
But there's a constraint. Basically, he's saying, look, I can't edit the weights of the frontier model.
Yeah.
Right. And my small models have all sorts of problems with, worldly wisdom anyway. So what can I do where I can still dynamically edit a prompt, which then, just like in systems, we say everything can be solved at the level of indirection and caching.
Yeah.
We're doing those things through this advisor model now. And then the prompt that comes out is not a GitHub check prompt or something. Like, no, this is just something that we're doing on the fly as well. Like, is that a good way to put it?
Yeah. It's dynamic prompt augmentation coming from a trained small model.
Because anyway, the big guy cannot remember my history of the last 2 years.
Exactly.
Right? I cannot keep memory there. I can't edit the weights. So what can I do with a smaller model that actually remembers my memory for the last year? I can RL the heck out of it. And then what I'm actually giving is so dynamic that that's the best we can really do.
It's similar to RAG, but if you think about RAG, you're only retrieving some paragraphs. Now you have an LLM writing advice.
Fascinating.
Yeah.
Sorry, go ahead.
The question that was coming to my mind was, so we talked about memory just being a document, right? That like, what can you learn from these transcripts?
Yeah.
The problem with that is that it can get very long if you want a lot of detail.
Yeah.
And so that's where advisor models could be helpful.
Yeah.
The alternate would be like a RAG thing that like this is a very large document, but you only pick a few chunks to put in there.
So there's many ways that this could evolve. I think the magic of memory is not really what you remember, but what you forget. Like I think really that's and also how it appears magically in your mind. And that's another dichotomy that we're thinking a lot about is sometimes you can think of things delivered to you. Sometimes you go and retrieve. Like if I told you, do you know like what was your grandma's sister something, you'd be like, oh, hold on a minute, and then you're actually retrieving, right? So, but sometimes things just are delivered to you, right?
Yeah.
I also want to say that look, React in the last year or two was dynamic prompts too.
Yeah.
Because I would do RAG and I'd create a new prompt and send it over to.
Yeah.
But I feel there is a distinction between what I call data versus metadata. This meta thing is instruction following, like, okay, but for Amit, by the way, the summary is this, as opposed to the 7 documents of a sales PDF where I'm retrieving paragraphs and summarizing. So I think what at least I understand is that what we spoke in the last 20 minutes is really about their instruction following prompts that are very specific to Alex versus Mate versus what RAG did, which was also did dynamic prompting, except that it was for the data piece, i.e. in the data plane of the Q&A versus the control plane of the Q&A.
Right, or the preference or the... Yeah. So it could be control plane or it could be personalization.
Yeah.
And I think both... Actually, I have a side story there. I heard from a VC, I think Sarah Kandazara was being interviewed, and she said something that I think is very, very good point. She said, personalization is such an incredibly important thing because, not because the performance is tremendously better necessarily, but because the moment you have an agent and you've spent 6 months, now you have some stickiness.
Yep.
So from a business point of view, it's like you don't like your employees, right? You work with someone and they may not be the best person in the world, but because they've been personalized, it's much more sticky. So to make agents sticky, personalization can be it's the game changer.
Yeah, you're right. Absolutely. Absolutely. Well, we talked about environment, which gets us to the last sort of leg of this three-legged stool, which is benchmarking and evaluation and all that. So in the last 12 months, how do you think things have evolved?
Yeah, so people started the data business is like the least understood part of the AI puzzle, right? So I think data was very basic, like people were annotating pedestrians in images. Then it became questions and answers that were very simple. Then it became very complicated questions and answers with rubrics. And that's how I think right now when you're training agents to answer complex questions that are open-ended, you create a rubric of saying every time if you ask a question about wine in Greece, if you include this you get plus 5 points. If you don't include that you lose 2 points. So it's a checklist of scoring answers, and that's how you train agents to do complex question answering. But the next step is now your agents are no longer going to be answering questions. They will be doing things. They will be collecting data and writing Python and so on. So there, in order for you to train or even evaluate an agent that's doing things, you have to let it do things. So you have to give it an environment which describes the state of the world when the problem starts, and it can actually fix a problem, and then there's a verifier that checks if the problem was fixed. So we're moving from questions and answers to environments. That's the number one thing. And I think frontier labs are all interested in environments to train their agents. Even first evaluate their agents and then train them. And also enterprises increasingly are now starting to realize, if I want to evaluate my agents or train my agents, I need environments in my tasks. So that is, I think...
and is there a standard that's emerging? And maybe we can compare it to the last 20 years of software testing. And what do you think? Like last 20 years of software testing. Let's set the context for software first before we get to agents. How was QA? How was... QA environment, stress environment. We had pre-prod environments. We had all sorts of environments. And we used to use the word environment back then as well. Is there any sort of adjacency between that environment and this new agent environment?
Yeah, the word that comes to my mind is mocking, right? Like we would mock all kinds of APIs and file systems and things like that.
Yeah, there were unit tests, functional tests, and so on. So I think because for the rest of the world, they know a few things from the last 20, 30 years. And then they want to say, this is actually the evolution of that. So that's the piece that we need to basically conclude today in some ways,
Yeah. And this being a continuum, right? So a lot of software testing was very deterministic, hard-coded. Like I'm going to do X and then Y and then Z and then I have A, B, and C expectation. If you miss any of those, there's some logic broken somewhere, right?
And there was zeros and ones.
Yeah. And then we started doing qualitative stuff. So for example, when you're testing a search engine, you're saying that, like, when I ask this question, these are the perfect answers, and you may not get all of them, but you'll get a fraction of those and you'll get a score for those. And I'll aggregate those scores across everything, and then I'll get an NDCG score or something like that, and I never want my search logic to regress from that. So that's kind of a little bit of evolution towards today's benchmarks. And now it's like, I don't even know what answer I'm going to get, and I have an LLM judge that will know whether it's hitting the right points or not. And then
so the LLM judge is probably the new thing, but what has changed in the way the process of evaluation and benchmarking? Has anything changed?
So there's like the fixed assertions, then there's like statistical scores, then there's LLM as a judge, and then there's agent as a judge, right? Like agent is essentially your environment. So let's say that I have an agent that makes recommendations on what to say when the customer says something, right? Who's going to evaluate how good this agent is? It can't even be in a single like LLM prompt. It has to be another agent that's maintaining state on the customer side. That like what you said now is actually very confusing because you didn't set the context before. So now we've gone from LLM as a judge to agent as a judge that's maintaining state. and trying to understand where we are in this process and is this thing doing the right thing or not.
And how does it connect back to terminal bench and everything that is happening in academia?
Yeah. So terminal bench is two things. It's a platform for running agents in the terminal. It says if you want to create an environment, it has to be a Docker container. It must have a file that describes the job. It must have all the files needed to do the job. Like, for example, a broken Python is the setup of the environment. And it must have some tests that verify if the job was done. Those can be programmatic or LLM as a judge. Actually, all of Terminal Bench is programmatic tests. One of the design choices made there is there will be no LLM as a judge tasks in Terminal Bench so far. Now, in next versions there may be, but now it's all programmatic. And then there's one difference between software and evaluation with environments. The difference is you write the tests to verify the software is good, but when you're programming the software, you have programmers. Now you're programming the agent by giving the environments. So imagine that you're programming by tests. You only the way that you will be programming agents, and that's why I think this will be a 10-year journey, because everybody agrees that you will be programming computers in 10 years, right? But how will you program computers? If the computers are agents, you will just say, here is like 20 environments, pass them, solve them, and then that's how they will learn. The same. So you only program by environments and basically tests.
I'm laughing because for the last 20 years, there's a set of people espousing test-driven development is the best way of development, right? Like write your unit test first and then write the code that passes that test.
Only problem is you eliminated programmers.
and is that happening with autonomous vehicles already? Today?
I'm not sure actually if they program them by... I don't actually know how... they're amazing. There's amazing progress, I can tell you that, but I don't know if they're programmed by... You need simulators there, because you can't create crazy situation. An environment would be, it's raining and there's this hard turn and there's a hidden pedestrian, you have to not kill them, right? So that's like an environment. An environment is a snapshot of the world right when you're going to be challenged. So I don't think it's very easy to do this for autonomous cars. Maybe in simulation there is. But that's how you should think of an environment. It's like the Matrix. You're gonna wake up and the world will be set up and there's like 5 people firing at you and you have to dodge the bullets and solve the puzzle. And that's why you mock everything, because you have to take snapshots of Splunk and the system at the bad time. You can't just have a live Splunk because you cannot snapshot it at those critical times. You have to mock it.
But again, going back to, we used to mock things even in software testing. The only difference was that the feedback went back to a human in the loop called a developer. And they would check this code into GitHub, and then it would go through the forward path of more testing and then being deployed in production. And again, the feedback from the customer in production came back as a bug, and the bug would then again get resolved in GitHub and so on and so forth. So there was a feedback loop there as well, and it would go through progressively harder environments and finally in production, right? So it go to integration environment, to QA environment, to pre-prod environment, to a prod environment. So what is different about this one is what I'm trying to figure out, because at the end of the day, the agent is also code.
Yes, I think one difference is the agent, unlike the software engineer, has to keep trying the same thing, hundreds or thousands of times. So both JEPA and GRPO need to try to solve the task hundreds or thousands or tens of thousands of times. So, and then they see what works. Right? So that I think is the difference. A human software engineer, maybe will iterate and so on, but they will not be pushing in production 10,000 times and learning what works like that, I guess. That's why you want a simulator, or that's why Terminal Bench it spins up all those Docker containers where the agent will try and they will learn, they will observe either reward or reflection But there is this. It's like basically, I guess, what's happening in the brain of the software engineer in a way.
And then with the integration cluster, which is actually flaky anyway, they're doing things in an iterative way, and that's why you give it a lot of pause before it gets to QA environments, and then QA to pre-prod, and so we have added a lot of, I would say, time delay to actually let this absorb. But there's a lot of iterations happening.
Yeah.
And I wonder if it's the same thing. The only difference is the fact that this is no human in the loop.
So I think the reason we go from like a developer's thing to an integration test to like whole release
QA
to pre-prod
Yeah.
is because there's a spectrum of cost of validation and fidelity of validation, right? Like with unit tests, I get very fast feedback, but it's not checking most important things. And when I put it in pre-prod, I'm paying massive cost for validating, but it's very close to customers validating it, right?
Yep.
And so there's always going to be a need for this continuous spectrum when there's this kind of trade-off that like, I made a change to the system, I can get feedback in 5 seconds that did I break something or not, versus I can spend, I don't know, $1,000 on LLMs to get proper feedback on whether it's working across all my test cases in its full glory or not. So I'm guessing you would eventually need something like that as well, where you have quick feedback mechanism that's low cost but low fidelity, and then expensive feedback mechanism.
Yeah, right now the quick feedback mechanism is the environments that we create, and doing this in enterprise is like, I think nobody's doing it in enterprise. I mean, we are trying in bespoke, but we're also doing it with Frontier Labs. So with Frontier Labs, we're doing it and we see kind of how to create it. One thing that, for example, that we're learning that's very important is you can create environments, let's say install or solve it. Let me give you an example. The task is, here is some training set, train a model for that gets accuracy more than 0.8. That's an environment. The environment has a training set, a test set, and so on. If you give this environment to the agent, if you give it a test set, it will just say, oh, I got 100% accuracy, I just copied the test. So it will cheat. So you're like, oh, no, I cannot, I have to hide it. You have to say, okay, you give me your predictions. The way Kaggle works is they don't give you the test set, right? So the point is, we're learning when we're creating those training camps for the agents that this is called reward hacking. In classical schools, we call it cheating. Right? Basically, if you give the test set to the student and you say, grade yourself, the student realizes, oh, wait, I can just copy these numbers and I get full reward. And then you can say, no, you're not supposed to cheat. But the problem is now you're in conflict. So the right way to create environments is design them so that they're not reward hackable. And sometimes the reward hacking can be very nuanced. Like, for example, you give internet access to the agent and they answer someone on the internet. We saw this in some experiments. It will literally download the answer. And you're like, no, you can't go there. So a lot of the work we do is creating environments and making sure they're reward hack proof. And then discovering this it requires other AI. So that's a big part of the process. The other one is making sure that you give like good habits, that they create solutions that are generalizable, so you can score on style. And the other challenge is, making those agents learn transferable skills is also very interesting. So there's a lot. Basically, you're building the training grounds for agents in the future, and there's so much to do there and to discover.
And is there a software that's coming out, or a company that will actually help people? Like, if you go back to the last 20 years, we had CI platforms, which are just orchestrators,
Right.
like Circle CI.
Right.
Just an orchestrator. You give it an environment. Sometimes it creates virtual machines and hosts it in Circle CI VMs that are running in Circle CI's cloud. But the tests are yours, the results are yours. They'll then dump all this stuff somewhere in logs and traces and things like that.
Right.
So we got some way to think about testing
Yeah.
through these orchestrators.
Yeah.
what will be the new world? Should I still continue to think of Circle CI as my orchestrator, or all of that is going to be a big change?
Right now,
And I'll tell you why I'm saying this,
sorry,
because pre-CI/CD, pre-Agile, these things didn't exist. You know, they were basically going 2 years of testing, 2 years of release cycles. And then we went from there to 1 day of, CI/CD, and every day cloud is actually being upgraded and so on. But it's still through GitHub and a human in the loop. Right? There was GitHub, there was human in the loop, and all that stuff. Are we just saying that we're compressing all that when there's no need for a GitHub or no need for a human in the loop, and that's how this thing is just going down that path?
Right now, environments are definitely human in the loop. So to create challenging environments that are tasks and verifiers, we have a lot of contractors and experts that create the tasks. And this is a huge value. Like, I do not think that you can fully automate the process of creating the environments, because in a way, the new knowledge comes from the humans. You can empower the humans, and you can make it easier for the humans to create the tasks, and you can also review the humans and make sure that the tasks are non-hackable and all those things. But there's always a constant distillation process coming from experts to the agents. And I think I don't think we'll be able to remove the humans completely from this. Like, all the data curation process involves a lot of actual human work.
Got it. How are you going to use benchmarking and evals from Terminal Bench for your software, for example?
I'm trying to process the question. So there could be two things here. One is, can we use the agents created with Terminal Bench to automate our software creation process? Is that the question? How could we use that?
Yeah. I mean, basically, how do you go beyond Circle CI and the old ways of writing software and prompts, and because we know our ways of doing CI/CD.
Yeah.
The question is, how do we there's a new way which is on top of that.
So I don't know if it answers the question, but the thought that comes to my mind is the biggest pain point in CI/CD is running a bunch of tests that don't need to be run. And if there's an agent that can look at the code change and figure out that run these tests, and if something were to break, 90% chance it would catch it. That would be amazing.
Interesting.
And like, people who try to do this with dependency analysis, but dependency analysis is like very coarse way of looking at, like, if a human were to understand the logic of what's the business logic, what is happening, what is this change about, and based on that decide that these are the tests that actually conceptually cover this functionality. And
I mean, we've done that with labeling tests.
Yeah. So I don't know if that relates to Terminal Bench, but this could be a task that an agent could.
And I didn't know that it's so significant to decide. Is it because it slows down the process? Or?
Yeah, because the speed at which I can develop software and deploy it is today purely gated by the speed at which I can validate the software.
I see.
And the cost of that validation is the cost of running all the tests, pushing the environments.
And by the way, there's a couple of real sort of stubborn issues with testing. One is that we don't do event-driven responses. So we put sleeps. Like, let's wait, sleep for this time, and we get a response. So on your laptop, it probably works fine. But now you put in a real environment with 500 other tests are running in parallel, and this thing took longer because you didn't have provisioned enough hardware to really get the response back in, let's say, sleep 20 seconds. And it fails. So there's lots of flaky tests.
Yeah, I see.
That just fail because they timed out. You know, and there's an environment issue, and people just don't have event-driven ways of actually testing things, where it's going to be like, just wait for the webhook, man. Don't put a sleep in here. That's a big issue in a lot of tests. And the other one is, again, it's in the sense of non-determinism. I think which ones to run at what point in time based on the code changes we actually made.
Okay.
But I think at the very least, we're going to come back and probably talk a little bit more about benchmarking and evals. Maybe we should even get Amit in here because he's trying to do some of those benchmarking evals as well.
Yes.
And maybe we can do a little bit of demo and things like that and run it like that too.
Yeah. Very good.
Awesome. Any final thoughts on today? What should people conclude?
So, in some ways, it feels like if you have an intelligent system and it has feedback, in the limit, everything is solved. Right? It's just that the process has a lot of weak parts, and we're just in the phase of strengthening that.
This is the anti-fragile book one more time.
No, it's going to take a lot of engineering to make it work.
I learned from mistakes, and that's why I'm great. Yeah.
Oh, that's the anti-fragile.
Nothing if it doesn't kill you, it makes you stronger.
That's also the reinforcement learning argument, as opposed to SFT. In SFT, but every time in real life, we see how much more you need to do SFT first. Like for training, for example, agents that work, 8B agents that work on terminal bench, nothing, 8B models on the terminal bench tasks were scoring 0. Like they couldn't do anything.
Say that again, repeat that again.
Yeah, so I'm saying terminal bench tasks are pretty challenging. If you put an 8B model or even a 32B model that hasn't been, very good, it's going to score very, very low. It's not going to do any of the tasks. So we spend a lot of time on research in a project called the Open Thoughts Agent, where we're like, okay, let's train an 8B model. And we said, let's do imitation learning SFT, or we do RL. RL, starting from the 0, is 0. It's not, basically, SFT, we created a lot of trajectories from high quality models, and then we managed to get to 9%. And then RL maybe gives you 1 more %. But the point is, to get to the anti-fragile moment, you better have a lot of good teachers you're imitating first, so you have a chance to be alive.
You're right.
And only the very, very last 1% you get from RL. So we actually had very hard time getting RL to move the needle so far. Whereas SFT with a high quality teacher is just orders of magnitude faster.
Imitation still works.
Imitation is a very good way to start, and it's going to get you 90% of the way there.
And it's all positive examples?
Yeah.
All positive examples?
Yeah, just ask a powerful model to solve, and then you SFT on the trajectories. That gave us 9%, which is very impressive for an 8B model. 8B models were 0. So anti-fragile and stuff is good, but it's trial and error. You just basically bang your head everywhere until you find.
That's what we call entrepreneurship.
Yeah.
Right.
Yeah.
Fascinating. But what else? Anything else to conclude?
Anything else? I think part of the reason we had this conversation was to understand where the state of the art was and where it has moved. So what do you see in terms of best models doing on terminal bench, and where was it, let's say, a few months ago, and what made the change happen?
Yeah, the frontier labs are moving very fast, and I think they have passed 50%. The terminal bench, now we released terminal bench 2, and so I think it's not saturated, but 60%, maybe 65%. Another thing I guess I want to say is there's the models, and then there's the agent harness. The agent harness has a huge role. So you can use an open source harness like Open Hands or Terminus, but Claude has its own harness. It's called Claude Code. And then there is Codex, and the harness has all the tools baked in, and I think that gives a huge significance. And there's companies that are only building harnesses, like going back to the first part of our conversation. And that, I think, seems better tools and better harnesses, even if you just use an off-the-shelf model, has a long way to go. So I think we will be, the models and the agents will keep getting better, but the benchmark is going to keep getting harder too. So hopefully it's relevant, in 6 months and a year.
So I understand the map. So there's the model companies providing models, and there's the harness companies like Open Hands, and what was the other one?
Warp.
How about Arise? Is Arise one of them?
Arise, I think, optimizes agents. I don't know if they have a terminal bench harness, but there's several on the leaderboard. But of course, the frontier labs make harnesses specific to their models too. So, but there's also agent companies that only make harnesses.
Yeah. And then there's the benchmark, which is what you guys do.
So, Terminal Bench and the Harbor platform is open source, but I think many other people can build benchmarks in their verticals using the Terminal Bench Harbor platform.
Got it. Great. Any last words, Alex? Based on, we talked about the industry. We went to, looks like we put an advisor model and a JEPA-like thinking and fine-tune prompts. Looks like people who have been using prompts for the last 18 months are actually in good shape. They probably don't need to get open source models. And finally, we talked about benchmarking. How should people, think of our next episode together, and what should we be talking about?
I don't want to make predictions. I think we're in the fastest changing, world I have ever seen in my lifetime. I mean, it's a fascinating time to be in the space, but it's so hard to know what's coming. And but I definitely think that we haven't solved continual learning. There's things we haven't solved. But it's fascinating. It's just such a fascinating space to be alive in.
Awesome.
What about any last thoughts from you?
I think I go back to how, at least, I look at this as a systems problem. A lot of it is systems now. And this idea of level of indirection and caching is a helpful way to think about things. And of course, separation of concern, hey, let's make this teacher model, this advisor model, and things like that. The way we used to think about separation of concern with software and components is how we're thinking about this as well. It just helps me think better, because I'm like, okay, I don't have to unlearn everything that I learned in systems development and data intensive applications and all that. Just, it's one step further in that.
Yeah, exactly.
Yeah, awesome. Well, thank you both of you for really doing this on a weekend. Merry Christmas, Happy New Year, Happy Hanukkah to all of you, and looking forward to 2026.
Yeah.
Great.
Thank you.
Great, thanks.